We're going to visualize how to obtain a C file from GitHub using the wget command, make some basic changes to the file using vim, and then we're going to compile using the Unix command line. At this point, you've reached this stage where we're going to obtain the file. This wget command brings the exact file from online. Now, first thing I'm going to do is I'm going to copy it, and then using Tabby, you right click, and then you have the specific file. You press enter and then press ls, you'll now see that we have a hello.c. We've downloaded it from GitHub. The specific reason why we need to use this raw GitHub user content, which is actually this file, is that if we were to download this file, let me show you what happens here. So if I run wget here, it's going to overwrite it and use a .1. But notice when I do vim hello.c.1, it has HTML code. We don't want this. When we're downloading it, we want to have the pure C code that we're going to be using to program in this course. If you tried compiling using GCC with this HTML file, you'll get a infinity errors. It would be very frustrating, and we want to avoid that. So what we're going to do is we're going to remove hello.c.1, and we enter back to our hello.c. So what we want to do is we want to enter in this hello.c using vim, and we see that we have this set of files, or this set of code. The first thing you're going to do is you're going to go in, you're going to change my name to yours, and you're going to change this email to yours. So we can change author name to Coach Marcus Freeman, and we'll say coachnd.mf@nd.edu. So you follow this step, and then the next step, you're going to go down here, and then you're going to change hello world to some comment. And since we're playing Ohio State, we're going to say go Irish, beat Buckeyes. Now, in order to save, we're going to do escape. You're going to hold the shift key, tap colon, and then you'll see this at the bottom with the colon, WQ, exclamation point, and press enter. We now see that we have hello C again, but let's go back to our directions. We've changed the names, we've saved the changes, we've performed these tasks. You'll notice here that I have a lot more compiler flags than you might have encountered in the readings. This is okay. I'm going to quickly go over each compiler flag and tell you what's going on. First, we have GCC. This is the compiler for the GCC on the Notre Dame Unix machines. -G is going to allow you to be able to use a tool called GDB, which is a debugging tool that you're going to learn about later in the course. And this helps keep track of everything that's going on in your code. -O2, which is capital O, not 0, not numbers or lowercase o, compiles to run optimally on Linux machines. So uppercase O, letter O, not number 0, 2. Next one is going to be standard C11. This compiles the standard 2011 that the C standard that was selected and designed and met upon in 2011. We do this using -std equals C11. Next, we're going to do -w all. This is all warnings up through 1999. W extra is after 1999. So these programming languages change over time. The next one is going to be W conversion. This is going to be really important as we start learning about data types. In lecture 2, you're going to see the real importance of ensuring that you're using single versus double precision formatting, for example. You want to ensure that as you perform a task in this C procedural language, that you move information as accurately and precisely as possible. So we're going to put W conversion. WShadow ensures that you don't have multiple variables in the same scope, and we're going to learn a lot about that later on. This will ensure that you write better, easier to read, and non-conflicting code. -LM stands for link math, and right now we don't have any link math, but in order to do advanced math, use the advanced math.h library, we need to use link math, and we're engineers, so we want to ensure that we're using link math. And so at this stage, we've got all our libraries, except we have one more here, WError. WError is going to force all warnings to be errors. And the reason we want to do that is because we want to write clean production quality code. So any warning that comes up is going to be changed to an error. And now we're going to change this to hello.c-o. That changes it to the object and executable. And we're going to have hello here. And nothing happened. That's a good sign. We type ls, and we see that we have the green hello and hello.c. In that next step here, /hello, we need to do that in order to run the executable, /hello, and it says go Irish, beat Buckeyes. So you can come up with any kind of creative thing that you run when printing this out. Just have some fun. Another thing I want to drive home, ls-l. We see the difference in sizes. Notice how hello in the executable is 10,960 bytes, whereas hello.c is only 294 bytes. So we're going to use makefiles in order to be able to compile a program and clean up these very large executables so we can move them between machines. That's why in this step, I'm going to ask you to delete hello. Don't delete hello.c. And we see that we have now reduced the memory from over 11,000 down to 294. And last thing, so this is going to be an important step here. So let me run this step again, where I run the executable. Now you can press the up button and go back to a certain step. And we run hello, and we see that it executes. Now you can use rm, and what's going on here is rm star.o hello. And the reason we want to do this is because when we start building larger files with our own libraries, we're going to build object files and combine them into an executable. I have this very large important note what's in red. This is a very common mistake that students make. What they'll do is they'll do rm, they'll do star, they'll accidentally put a space, and they'll put .o, and then hello, right? Hello is deleting the executable, and the object files is what we would delete. If you leave a space here, what this star means is it will try to delete all of your files in your entire file hierarchy. In fact, it'll try to delete the entire Notre Dame server. Now, there are protections, so you won't delete other students' code, but you will delete your own. And this becomes an issue if you are trying to, say, submit an assignment in 30 minutes. That would be a real problem. So you want to be very careful when deleting and when you make files to ensure that you're only deleting the files that you want to. So I'm going to press enter there. Here this says can't remove .o, no such file or directory. We see that there are no object files here. That's fine. We haven't created any yet. So it turns out it's doing exactly what we want it to do. We want it to be safe, but we also want it to be performing the tasks that we want to do. And then last, but certainly not least, we do clear in order to clean up our screen.